So hello everyone, this is the final paper of the part 1 series in mind-blowing AI technologies in 2025. So here what you are going to see is smarter EV charging with AI agents, and this is one of the good papers I have viewed till now. It's an EV charging system considering power dispatching based on multi-agent LLMs and CGAN. So what is the problem here is when generally people power in the power station, sometimes the power gets too much heavy load and many fluctuations occur. So to avoid these kind of things, and also sometimes the power station costs cheaper compared to other times due to the no supply or high supply. So depending on this, we are going to solve the problem to make the users more efficiently use the power station. So the core idea is we are using a dual agent framework for EV charging. Here we had two agents. One is a user agent, which will interact with the EV customers and gather their preferences, their personal charging solutions, and will make plans to enhance the user satisfaction. At the same time, we also have EVCS agent, which is the manage charging stations. That will see when will be the optimized pricing and when it's available real time. It will take information about the power grid and make the overall utilization good. So how this multi-agent system works is first a user suggestion. As a right side you can see, it will just view what are the user, where they're going, the navigation and their performance and memory. So preference and memory, based on all this user data, LLM is trained, and this will negotiate with the EVCS agent. So this is the EVCS agent, which will also have data like what are the people who are coming, historical data, what is the current status, and time LLM, how much time each and everything. And based on this, another LLM is trained. So these two are going to negotiate in this negotiation platform, where they will see whether to adjust the platform, or adjust the time, or when to come to the EV station, or when to get the supply, etc. So what is the user agent? The user agent helps the EV drivers to find the best charging station. It will gather the map, time, weather to understand this situation, and it will use the rack to re-rank all the informations on which is the first preference EV station compared to others. At finally, the LLM model will get a personalized charging recommendation in real time. At the same time, there is the EVCS agent, which is the agent of the charging station, which will, based on the historical data, will re-rank the station's rank and see which is the nearby people who will be coming and visiting the places, and it will help in predicting the future load demand also using the time LLM. And these two will be communicating in the negotiation platform. This negotiation platform is where the user agent and EVCS agents connect and will having ranking options based on the user preferences. So it enables the dynamic privacy protect discussion where the agents negotiate and will agree on the best charging price in real time. Yeah, you can see the template. Based on this, how the agents will the user agent will give the idea, and based on this it will suggest which one to look. And also the main thing is there are not many data available for training the agents. So that's why we are going to generate some data using the CGAN, which will generate the realistic training data, which will be useful for the training the system. So further, the LLM enhances semantic accuracy. As you can see, left side, so I can show you. So this is a simulation done to research more about the agents, about this EV agent. So to know it, they have 100 simulated EV users placed in 6 km radius in Shanghai, as you can see in the right side, and each one have different preferences, the states of charges, etc. And the charging prices are dynamically set between 0.8 to 1.2 and base rates. So some noises are also added in the data to test the robustness of the model. So what are the results? As you can see from this table and the results, the selection is the fast charging options. Like here is a tilt, which is the first when the speed is preferred, while the slower stations like AV is for slower charging. So based on this, the systems will communicate, and based on the user preferences, it will suggest which one is the more compatible one. So yeah, that's how the choice. Meanwhile, some weather conditions are also further refined these choices. Based on sunny day, it is better to power the near station compared to other days when it's cloudy days, where it is further, like these kind of things. So what are negotiations with different LLMs? So they also use different LLM negotiation platforms. So check which one is the better. So as you can see, both are giving somewhat similar, but GPT-4 offers a lower price strategy, whereas DeepSeek adjusts the prices and do not just aim for the lowest price, but will carefully adjust the prices. So these model prioritizes user preferences and situation status differently, so which gives different results. And how in the future they are going to enhance this? The future research directions are, first is the investigate more comprehensive data, so based on travel platform patterns, the energy policies, etc. At the same time, the long-term impact of the charging behaviors is also noted, like the dynamic pricing assistance or mobility shift. And the economic and social factors also influence based on the community. And for the LLM itself, they have scale to affect their performance and resource for compensation. So yeah, this is the complete project on EV station. I hope you like this series. Thank you.